In this Follow Me video, we'll look at Session 3, 03 Accumulators and Functions and Methods, and we'll look at M3R, Unit Testing. Go ahead and make it so that you can see both the video and your pie chart like I'm doing here. Now, unit testing, which is what this thing is about, is the following idea. In unit testing, the software developer develops the software in chunks, small chunks. And as they do so, they test each small chunk independently of the other small chunks. The software developer doesn't proceed until a small chunk is correct and then moves on to the next small chunk. In that way, you build upon correct code. Finding bugs after you've got a bunch of code is much, much harder than finding the bug or bugs in a small chunk of code. So the time is well invested to do what's called unit testing. In our course, the units are typically going to be functions, or later in the course, methods in a class. The unit can be an entire class itself, or even a whole module. The size depends upon what software this developer is developing. But the whole idea of unit tests is you're testing one chunk, one piece of the program independently of the rest. Let's go ahead and do the first to-do. So put your name there where it says put your name here, and then mark that to-do as done. As we've done in previous projects, set the source folder by right-clicking on it and selecting Mark Directory as Sources Root. That will make it so that PyCharm doesn't flag the things being imported from this folder as errors. So again, right-click on SRC and then mark it. Go ahead and make sure that you can see both the video and this thing, and your PyCharm. Let's see what it goes. So first of all, it starts with defining main and then running test distance for main. It then defines run test distance, and then they call distance. Distance, which is the function that we're going to be testing via the test code run test distance, is down here. And we've already written all the code. The purpose of this module is have you understand how you yourself in the next module will be doing testing. So here, after the code is defined main and defined run test distance and defined the distance functions, it then calls main, that's against the left edge there, causing the code to return back up to the definition of main, and from there to call run test distance, which itself will call distance several times. To-do 3 explains the process of writing tests. You're to read the following, we'll just go over it here orally, to learn about how unit testing works. So look at the distance function up above. It's the function that we want to test. So I'm scrolling up here to show you there's the distance function, and there's its specification. Now I want to emphasize you can't possibly write tests for a function that you haven't already read the specification for that function. You have to know what the function does, or is supposed to do, to write a test for it. So this one takes in an RG point and returns the distance that point is from 0, 0. So for example, if it takes an RG point at 3, 4, the function returns 5 because of the way 3, 4, 5 triangles work. These type hints here are just to make the dot trick work better. We'll supply them for you, but you don't need to know anything about them. So again, the first step of the testing process was to read the specification of the function that you want to test. The next step is to write the tests. So we're going to go see how that works up there in the run test distance. The first part of writing the test is that the human tester figures out the correct expected answer on a particular test case, usually by working the problem by hand or trusting a test case provided by some outside source like the instructor. So for example, we're going to see that in the run test distance function, the human tester realized that run test distance should call distance. In test 2 is the one that actually is referenced down below. The human tester first asked, what if we tried to find the distance that the point, RG point 3, 4, is from the origin, is from 0, 0. The human tester knew that the answer is 5 and stored it in a name, expected. So again, step one of writing a test is to have the human tester figure out the correct or expected answer on a particular test case. Step two is that the testing function calls the function that it's trying to test and then stores the returned value in a variable. So here, the test was to see how far, see what the distance returned on 0.34. We figured out that the expected or anticipated value is 5. The code calls distance on that RG point at 3,4, stores it in the name answer, and that's the second part of the testing, of writing the test. The third and final part of the test itself is to print both the expected answer and the actual answer, or if you were fancier, to write some what's called if statements to see if they're the same. The combination of all three of these steps forms a test, and the code passes the test if it prints for expected the same thing as it prints for answer. So again, here's another test where we chose the RG.11, figured out that the expected answer is square root of 2, and then called the distance function and got back the answer there, and then compared those two answers. Now, if the code failed the test, the software developer uses tools like what's called a debugger to find the source of the error and fix it. And you'll learn lots about that over the next several sessions. The error might be in the code, as in the above example, or in the test. We're in the process of running this. Notice that test 3 and test 1 both passed. The expected equals the actual. But test 2, where the expected and actual are different, test 2 exposes a bug in the code. We're not trying to figure out what that bug is as part of this process. We just want to see the testing process. So testing is a huge topic, but unit testing, like we did up above, is a start, and you'll do it in every single session from here out. One more thing, students sometimes confuse print and return because you will almost always test your functions by using this capture in a variable and then print the variable approach. From that alone, it looks like the function could have just done the printing. But in real programs, functions rarely print anything. They return values for other functions to use. Think about a program that is controlling the space station. It's not printing much. It's instead computing all sorts of sensor information and making automatic adjustments and who knows what, with functions communicating between themselves by returning values. We teach you processes that scale up, so we'll demand that you use so we'll demand that the functions that you write typically return a value rather than print something. To summarize, to do unit testing, you do 4 steps. The first preliminary step is to read the specification of the function that you're testing. You can't possibly write tests for something that you don't know what it's supposed to do. So you read that specification. Then for writing the tests themselves, that's 3 additional steps. First, the human tester figures out the expected or anticipated value on a test case that the human tester chooses. Then you have the program call the function being tested and store that in an answer. And then in step 3, the code prints the expected and actual answer, and then the human can compare those two as the final part of the testing process. We'll use exactly that same testing process throughout the rest of the course. You'll start doing so in the very next module. One more time, here's the structure. You first look at the specification of the function you're testing, here the distance function. Then, to write the test cases, you put several tests, enough so that passing them would give you confidence that the code is correct, several tests where each test is like the 4 lines shown here. First, the human decides what to call the function being tested, what arguments to use for it. So distance of what? The human then, the human figures out by hand or using a calculator or some means other than running the code what the correct answer is, what the expected answer is. The code stores that expected answer in one name, expected, calls the function being tested here, distance, on the test case, for example, RG point at 3, 4, and then captures that returned value in another name, here, actual. And then the code prints expected and actual, and the human can look at the two to see if they're the same. Fancier testing would automate the process of comparing the two, but we'll just keep it simple here for the first part of this course.